Welcome to Study Loop.
This is the answer to Chapter 23, problem number 51 from the Smith Organic Chemistry textbook. This problem asks us to synthesize these four molecules from ethyl acetoacetate, and we're told we can use any other organic or inorganic reagents. Okay, so we're going to obviously use the techniques that we learned in this chapter in order to accomplish this. And so for A here, we're going to start from ethyl acetoacetate, and we will deprotonate that with sodium ethoxide. And then, since we're trying to add an ethyl group, we will use ethyl bromide. And then we're going to follow that step with some aqueous acid and heat to decarboxylate. And that is going to give us our desired product here. Okay. So that's part A. For part B, we are going to do really just the first step a second time, since this time we're trying to add two ethyl groups. Okay, so we're trying to add two methyl groups this time. And so we'll do the first step from part A twice, but we'll use methyl bromide rather than ethyl bromide. So that is going to look like this. And then we'll do that a second time. To add that second methyl group. And then we will do the aqueous acid and heat. And that is going to get us to our desired product there. Okay, so that's part B. For part C, we're actually going to start from that product that we made in part B. So starting from here, okay, we're trying to now add a methyl group to the other alpha carbon in this ketone. And so to selectively deprotonate that less hindered alpha carbon, we'll use lithium diisopropylamide in THF. That is going to selectively deprotonate this carbon. So we'll have our lone pair and negative charge there. And then treatment with methyl iodide. Oops. Move that down so it's visible. There we go. That gets us our desired product for part C. Okay, part D is going to be similar to part C, but we're trying to add a methyl group to the right side of the molecule. So we're trying to make a terbutyl group. And so again, we'll start from the product from part B. This time, in order to selectively deprotonate the other side, we'll use potassium terpbutoxide in T-butanol. Okay, and that is going to allow us to deprotonate the more hindered position. So now our lone pair and negative charge are there. And then again, just as in part C, we can use methyl iodide to add a methyl group there. And so parts C and D are good because they show complementary techniques for deprotonating either alpha carbon when there's a difference in sterics between the two of them. Okay, so that's parts C and D. Here again is A and B, and that is the answer to chapter 23, problem number 51.